On to example 6 of rationalization by conjugates. We're looking at yet another complicated example, but hopefully it'll be a little bit less complicated than the last example because we don't have addition or subtraction in the numerator. So less foiling, thank goodness. All right, so here we're specifying that x and y are both greater than 0. That way we are not going to be dividing by 0 or doing anything weird with that. Nor are we taking the square root of negative numbers and getting something imaginary. So we don't have to worry about a 0 denominator, and we don't have to worry about taking square roots of negative numbers. So how do we go about simplifying this? We're going to be using the exact same technique we have in the previous several examples. By conjugation is how we're going to do this. So rewriting the original expression up here, I have 5 root x in the top, I have 2 root x plus root y in the denominator. And I'm going to multiply, this is the key step for all of these problems, is multiply top and bottom by the conjugate of the denominator. So here we have a plus, we want a minus. So we have 2 root x minus root 7, okay? And then have the same exact thing in the denominator. And then we're going to put parentheses around everything so it's clear that we're multiplying. Okay, FOIL. So we have this 5 root x times the top. So we're going to take this and distribute it to each of these guys. So we have 5 root x times 2 root x minus 5 root x, because of that minus sign, we have the minus, times root y. Okay. So that is just the numerator. Only 2 terms this time, thank goodness. All right, now in the denominator, we're making use of the difference of squares identity, which means that when I multiply these two things out, the conjugates of one another, it's going to be this times this minus this times this. So this gives us 2 root x squared minus root y squared. Okay, simplify. How do we do this? Well, I have 2 roots being multiplied here together. They have the same root, so this ends up being an x squared, square rooted, and I also have this 5 and 2 that are being multiplied. So I have 10, because of these two guys, times root x squared, because I'm combining these 2 root x's under the same roof. I'll cancel the square root and the squared in the next step. I have square root of x times square root of y. Here, I'm going to combine those under the same roof, so I have square root of x, y. Okay, so that handles the numerator. Simplify the denominator. I have a product on the inside of this power here. So the power can be distributed to each of the factors independently. So that gives me 2 squared times square root of x quantity squared. And then we have the same thing here where I have square root of y squared. Well, that's just going to be y. Not absolute value in this case, because remember we said that x and y are greater than 0. So we don't have to worry about y ever being negative. So y will be sufficient. Don't need absolute values. Okay. Simplify further. We have 10. Okay, we have square root of x squared. Normally that would be the absolute value of x, but again, we don't have to worry about x ever being negative because we said it's not. So that's just 10x. And then we have minus 5 x times y. And since x times y are both positive, we don't have to worry about taking square roots of negative things here either. So this restriction is very helpful for simplification purposes and definition. So this is completely simplified on top. And then here in the denominator, we have 2 squared, that's 4, times square root of x squared, that's just x. Again, because x is positive, we don't need a absolute value bars. And then we just have a y. All right, so at this point, this is completely simplified. We cannot simplify this anymore because, sure, we have a 5 factor in 10, we have a 5 factor here, but we don't have a 5 in the denominator for which we can cancel it. All right? And you might be thinking, oh, I want to just cancel this x here and here. But as I said before, you can only cancel stuff in division when you have things being multiplied, such as if you had like 2 times 3 over 2 times like x plus y, or something random like that. These things are all being multiplied, so these can cancel. However, you cannot cancel in circumstances like this, where you have x being added, something with x being added to something else. You cannot just cancel these. They need to be multiplied on both top and bottom. Here they're being added or subtracted. So you're stuck. Okay? So in this case, we are done. That's the end of this example, and I will see you in example number 7.